Integration by partial fractions. This is going to be a technique of integration. Let's take a look at a problem in Algebra 1 or Algebra 2 where we take a look at two quotients and put them together and make another quotient. So back in Algebra 1 and Algebra 2 you were given two quotients, try to find a common denominator and put it together into one answer or one fraction. We're going to do the opposite. We're going to start with the one fraction and we're going to try to pull apart what two fractions must have been used to put those two together. Now, you have to take the denominator and you have to make it into a product of linear factors. Each one of those linear factors is a denominator for one of the fractions. We don't know the numerator, so we'll call it A. We don't know the numerator of the other one, we'll call it B. Let's go through the process of trying to find A and B. We're going to do that by using a common denominator, as you see here in red. And what's nice about this is multiplying by the common denominator is going to eliminate all of those denominators. And here's the next step. You can see all the denominators are reduced. And then we're left with the expression in the numerator, which is x minus 13. And then we're going to take A and multiply it to the linear, and multiply B and multiply to the linear as well. I'm going to gather up all the x terms, put them together, gather up all the constant terms, put them together. Now, since these two expressions are equal to each other, I know that the coefficient of x will equal the coefficient of x here, which is 1. And the constant here will equal to the constant over here, which is negative 13. On this next slide, I go ahead and equate them. Now we have a system, just like we did in Algebra 1. So I'm going to use the elimination method. I'm going to multiply the numerator by 3 here, and then solve for B, and then solve for A. Once we have those two numerators, we now know that this quotient expression is the sum of these two partial fractions where I know the numerators of each of them. This is a big advantage because I know how to integrate something like this, where this looks very difficult. In our next example, I have a quotient expression. You can't use the method of partial fractions until you have a proper fraction, which means the numerator, the degree of the numerator has to be less than the degree of the denominator, which is not happening here. So we're going to go through some long division to get the quotient. And after we do that, we will get our remainder, which is 4, and put it over our divisor. Now this is where we're going to use the method of partial fractions, which I have over here. I've gone through the process of multiplying by the common denominator. And again, the expression here is equal to A times the linear factor that's left, B times the linear factor that's left. Group up all our x's, group all our constants. Now you can see there is no x expression on the other side, so A plus B will be equal to 0, and the constants will be equal to 4. And once we eliminate, we'll be able to find our two numerators, which I have substituted, and we can resubstitute our integrand here and integrand each one of these terms. And we can take the natural logs and we can pull them together into one expression. All right, let's take a look at this problem. This looks like a laborious problem. Notice that the x squared plus 4 needs to be broken down into its linear factors. And once you have these three distinct linear factors, then you can set up the three fractions like I have here. If I go through the process that I did before and eliminate all the fractions, I'm going to get this expression right here equal to the numerator over here. Now there's another technique where we don't have to multiply everything out, and I want to show you that right now. So let me take a color here, A, and I would like to find A right here. Now to find A, what I'm going to do is I'm going to set every x value equal to 2. Now why? Because this will make this go to 0. Okay, so I'm taking this expression and I'm going to put 2 in there, and I will get the number 4. And then I will take the number 2 in this expression, I will get this. And the nice thing about this, 2 in this expression and 2 in this expression will go to 0, so these will be zeros. And now I can say A is equal to 1 because now I just have this and this to work with, and then I get A equal to 1. Now let me change my color. If I want to solve for B, I want to have this, then I'm going to let x equal to -2. That's what will make the denominator go to 0. So I'm going to make x equal to -2. Now when x is equal to -2, this expression is going to go to 0. This expression right here will become this. This expression right here will go to 0. And if I put -2 into here, I'll get 36. And then it's a matter of us working with this expression and 36, and we'll get b equal to 3. Now to get c, what you do is you take a look at c, and you're going to let x equal to 1, because that's going to make that go to 0. So now to find c, I am going to let x equal to 1, which will make this term with the a go to 0. And here, letting x equal to 1, that will go to 0. And then letting x equal to 1, I'll get some kind of expression. Put x equal to -1 here, I'll get this expression, and then solve. And I get these answers a lot easier than me having to actually multiply everything out. We attribute this method to a gentleman called Heaviside, who developed this method of finding a good substitute. All right, so let's take a look at the problem again. This is the same problem, and I want to show you how we go about doing it. We actually don't write out as much as I was writing out before. What we do is we take and we hide this portion right here. If I'm going to try to find A, I hide this expression right here, and then I want to find A right here. So I am going to let x equal to 2, and x is equal to 2 in this whole expression. So A will be equal to 6 times 2 squared minus 8 times 2 minus 4 all over 2 plus 2 all over 2 minus 1. And so this will be 24, take away 16, minus 4, all over 4, and this answer will be 4 over 4, and so A is equal to 1. So we have this expression equal to 1. Now, is that the expression we got before? Yes, you can see A is equal to 1. All right, now let me change my color. If I want to find B right here, and let me take my pointer, and I'm going to hide this portion right here. Okay, and now I'm going to let x, I need to get my pen, x equal to -2. Why is it -2? Because that's what that denominator is. And so b will be equal to 6 times -2 squared minus 8 times -2 minus 4 all over, and then this will be -2 minus 2 times -2 minus 1, and I'm going to get 24 plus 16 minus 4 all over -4 times -3, and that's going to be 36 divided by -12, which is equal to -3. Now let's go back and see if that's what I got. -3, I should have got a +3, so somewhere I'm making a mistake, and yes, that should have been a positive answer right there. So then I get +3. All right, and then we're going to go through the process again. Let me get my pointer. I'm going to hide this portion right here. I'm going to get a different color. I want to find what C is equal to. So I'm going to let x equal to 1, because that's what's going to make the denominator go to 0. And so I get C equal to 6 times 1 squared minus 8 times 1 minus 4 all over 1 take away 2 and 1 plus 2. So that's going to be 6 take away 8 take away 4 all over negative 1 times 3. So that's going to be negative 6 all over negative 3, which is equal to 2. And let's take a look at if we got 2 before. Yes, we got 2 before. All right, so we're using that algebra technique, but we're covering things up so that we don't have to show the division and the groupings that we were doing before. Okay, so again, here's another problem, and they show you the step-by-step going through the process. Again, what you're going to do when you're trying to find the replacement for this problem, we know that we are going to, let me go ahead and write this up. We know it's going to be an integral, and it's going to be a over x plus 1 plus b over x minus 2 plus c over x plus 2 dx. So this is helping us rewrite our integral. And what we do is we cover this portion up right here. That's what they're showing here, covering it up. And since you're trying to find a, you are going to let x equal to negative 1, and that's what this process is showing, and you're going to get negative 1. Then you cover this portion up, and if you're going to find b, you're going to have to cover the x minus 2 up and allow x to be equal to, we're covering up the b, and I think, I think I wrote it wrong. It should have been x minus 3, not x minus 2. So it's 3 here. And so I'm going to substitute 3 in for all the terms right in here. And then I find my answer, 4/5. And then I go over here and I cover up. And I'm going to substitute all my x's to be negative 2 here and reveal that. And this is the end of the screencast.